Hello and welcome to Nikolai's genetics lessons, and today we are going to solve a statistical problem, combinatorics problem. And why I post such problems on my channel? Because all modern genetics, bioinformatics, computational biology uh, is based on this type of computations, on the statistical methods and combinatoric methods. So uh, here's a problem. From a total of 5 boys and 4 girls, how many 4-person committees can be selected if the committee must have exactly 2 boys and 2 girls? As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. And today we are going to use some methods that you can be familiar with from your genetic course. And today we are going to use Punnett squares in order to solve this problem. So take a look. For example, we have 5 boys, and let's name them, instead of giving real names, just boy number 1, 2, 3, 4, and 5. So imagine that this is unique names for each individual here. So how many different combinations we can make with these 5 boys if we just need 2 boys? So let's build simple Punnett square. So another boy number 1 here, 2, 3, 4, and 5 here. So now let's build simple Punnett square. And this is going to be a square 5 by 5. So 5 columns and 5 rows. So 1, 2, 3, 4, and 5. So now let's list all the possible combinations. And first I want to show you what we are going to get here on the diagonal. And instantly you would see that it's not possible from group of 5 people to choose 2 people number 5. Or let's say this is John. We cannot choose 2 Johns because John is only present here as a single person. So we cannot use this combination, so we have to exclude them. And now let's think what other unique combinations of 2 people we may get from a group of 5 people. For example, 2 and 1, 3 and 1, 4 and 1, 5 and 1, and 3 and 2, and 4 and 2, 5 and 2, and 4 and 3, and also 5 and 3, and 5 and 4. Why I am not completing this part? Because here we are going to get repetition. Take a look. For example, we are going to get here in this cell 1 and 2, and this is the same. Take a look. 1 and 2 is the same as 2 and 1. Again, do not forget that each number here stands just for individual. So if we choose, for example, John and Martin, this is the same as Martin and John. So that's why, for example, again, here we are going to get 1 and 3, and this is the same as this 3 and 1. And 1 and 2 here is the same as 2 and 1 here. And if you're confused, we can basically use the same numbers. For example, we can say 3 and 2, and this is the same as 3 and 2 here. So we do not use all these squares here. So let's count how many combinations we have. 1, again, unique combinations. 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 unique combinations. How from group of 5 boys we can choose 2 unique combinations of boys. So boys cannot be repeated. Now do not forget that we have to choose 2 boys out of 5, and we also have to choose 2 girls out of 4 girls. So 5, we choose 2 boys out of 5 boys, and now we have to choose 2 girls out of 4 girls. Again, we are going to use the same rules. So we have 4 girls, and this is going to be girl number 1. So this is boys, just for your, or we can use the sign from genetics, and we can use this sign from genetics to designate that this is going to be girls. So girl number 1, girl number 2, girl number 3, and girl number 4. And again, these girls can make following combinations. We are going to build again another Punnett square. It's going to be smaller because now we choose 2 girls from 4 girls. Again, we cannot get 2 same girls. And our Punnett square is going to be as follows. So 1, 1, 2, 2, 3, 3, and 4, 4. Here we have to exclude, and we also have to exclude all these combinations because this is going to be just a repetition of these combinations here. So let's count how many unique combinations we may have. We may have 2 and 1, 3 and 1, 4 and 1, 3 and 2, 4 and 2, and 4 and 3. Again, this is not 21, 31. This is girl number 2 and 1, girl number 3 and 1, girl number 4 and 1, and so on. So each number here stands for unique individual, and this is how many combinations, unique combinations we may get. So 2 and 1, 3 and 1, 4 and 1, 3 and 2, 4 and 2, and 4 and 3. So again, for example, such combinations as 3 and 2 is the same as 2 and 3. So we have again 1, 2, 3, 4, 5, 6 such combinations of girls. So 10 combinations of boys multiplied by 6 combinations of girls would give us 60 unique combinations of committee of 4 people made by 2 boys and 2 girls. So as you see, this is answer C. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. And see you in the next video. Goodbye.